Am I audible? Can you hear me?
Yes, ma'am.
Okay. So last time we started with the axis cavity preparation, and in that we have seen that there are for cavity preparation there are some principles are there. Similarly, for axis cavity preparation, there are some principles. What is axis cavity preparation? It is the first step of the root canal treatment to get the access to the pulp chamber. In root canal treatment, we remove the necrotic pulp, damaged pulp. We remove in root canal treatment. And for removal of pulp from the pulp chamber and from the root canal, we need to prepare a cavity, and that cavity is called axis cavity preparation. Last time we started with the axis cavity preparation. For this type of cavity preparation, we have to follow certain principles. Out of which first principle is outline form. Last time we have seen that outline form, it is the form which is similar of the shape of the external surface of the tooth. It depends on size of the pulp chamber, isn't it? Second step is the convenience form. So cavity should be adequately large so that we can easily remove the pulp tissue from the pulp chamber and from the radicular dentin, and we should easily able to see the canal orifices. And third principle is the removal of remaining carious dentin and defective restoration. So, why we do the removal of remaining carious dentin? See, this carious dentin consists of bacteria, it consists of toxins. Okay, so by removing this carious dentin, we remove the bacteria, we remove the toxins, and one more thing is we have to remove is defective restoration. See this, with this we are removing the toxins. With this we are removing the chances of reinfection of the pulp chamber and the root canal. And with this defective restoration when we are removing the chances of clogging of restorative material inside the canal orifices. Okay, so by removing carious dentin and by removing defective restoration, we are removing chances of infection, we are removing the bacteria, we are removing the toxins, and we are also removing the restoration that may clog in the canal orifices. If the canal orifices get clogged, you cannot remove the pulp tissue from the radicular part of the tooth. Okay, we cannot remove the pulp tissue from the root canal cavity. Okay, next is toilet of the cavity. See, because of preparation of axis cavity, there is debris formation. Because of removal of carious dentin, because of removal of defective restoration, there is debris formation. This debris we have to remove with the help of some irrigant, that is water. Mostly we use water or saline, and this is called toilet of the cavity. Sometimes the pulp chamber is calcified. Sometimes there is a secondary deposition. Sometimes there is a necrotic material inside the pulp chamber, it is present, and that we will remove by washing the cavity. It is called toilet of the cavity. Next is these are the laws of cavity preparation. Okay, so what are the laws of the cavity preparation? See, first we have seen the principles of the cavity preparation. Next is the laws of cavity preparation. Means by preparing a cavity, we have to follow certain laws. Okay, so what is the laws of cavity preparation? First is the law of centrality. So what is the law of centrality? The floor of pulp chamber, it is always located in the center of the tooth at the level of the C junction. See, at the level of C junction, Means in this you can say that you can determine the floor of pulp chamber by locating C junction. So where this law of centrality is important to us, when the when the pulp chamber it is totally calcified. In that case you cannot find the pulp chamber. In that case you have to remember that you are not going to beyond the floor of the pulp chamber. If you go beyond the floor of pulp chamber, what will happen? You will perforate in the percussion area. So when the pulp chamber it is calcified, in that case you are not able to differentiate this floor of pulp chamber. Means at that time your reference point will be the level of the C junction. Okay, so in case of calcified pulp chamber where the floor of pulp chamber is not clearly demarcated, in that case you can take the reference of the C junction. Means you are not supposed to go deeper than the C junction. If you go deeper than the C junction, you will perforate the floor of pulp chamber and you will land up in the percussion area of the roots. Am I clear? So this is the law of centrality. With this you can locate the pulp chamber. Okay, so law of centrality means at the C junction, the floor of pulp chamber, it is located at the level of C junction. The clinical significance of this law of centrality is that whenever the pulp chamber is calcified, you should take the reference of C junction because the floor of pulp chamber is not clearly demarcated. Next is law of concentricity. What is the law of concentricity? It means that the external surface of the or external outline of the tooth, it resembles with the outline of the pulp chamber. Okay, so if the tooth is at the level of C junction, if the tooth is ovoid, then the pulp chamber will be ovoid. At the level of C junction, if the pulp chamber, external surface of the tooth is, if it is rhomboid, then the outline of the pulp chamber will be rhomboid. At the level of C junction, if the external surface of the tooth is oval, it means that the outline of the pulp chamber at the level of C junction will be oval. This is law of concentricity. What is that? The wall of the pulp chamber are always concentric to the external surface of the tooth at the level of C junction. Am I clear? Means the external surface of the tooth, it exactly resembles with the external surface or outline of the pulp chamber. Only thing is the size is small. This is the law of concentricity. So whenever the pulp chamber it is calcified, in that case pulp chamber outline it is not very much clear. In that case you have to see the what you have to know what is the external surface of the tooth at the level outline of the external surface of the tooth at the level of C junction. So it means that if it is oval, it means your pulp chamber will be oval. If it is rhomboid, it means your pulp chamber will be rhomboid. Okay. Location of the C junction. Okay. The distance from the external surface of the clinical crown, it is similar to the, see, it is similar. See, the wall of the distance between the wall of the pulp chamber to the external surface of the tooth, it is equal from all the sides at the level of C junction. Means the pulp chamber, it is exactly centrally located at the level of C junction. This is law of centrality. This is the law of centrality. At the level of C junction, the pulp chamber, it is exactly centrally located. It means that the external surface of the pulp chamber, the distance between external surface of the pulp chamber and external surface of the tooth, it is equal from all the sides. Okay. Next is law of symmetry. See, if you make a symmetrical line passing through the tooth mesodistally, means if you prepare two halves, one buccal and one lingual by a line which is passing mesologically, this will divide the tooth symmetrically. Exception is maxillary molars. Means what? Except for maxillary molars, if you draw a line nasodistally which is passing through the pulp chamber, it will divide the pulp chamber in equal halves. It will divide the pulp chamber in the equal halves. Now, next is color chamber. The pulp chamber, it is always darker than the surrounding dentin. Okay, so pulp chamber will be always darker than the surrounding dentin. Next is orifice location. So this orifice, what is orifice? This is the root canal openings in the pulp chamber. What is orifice? It is the root canal openings in the pulp chamber. So this orifice we have to look at. These are very small. Its diameter it is 1 millimeter and calcified canals it is less than 1 millimeter. So it is very difficult to look at. So you have to like you have to apply some laws to locate these orifices. So these orifices they are always located at the junction of the floor, that is pulp chamber floor and the walls of the pulp chamber. So they are not never ever located in the center. They are always located at the junction, the line angle junction, which is formed between the floor of the pulp chamber and the wall of the pulp chamber. Okay, so this is one for the orifice location. This is the one rule. Next rule is these orifices they are always located at the corner of the pulp chamber. They are not located on the wall of the pulp chamber. They are located at the corner. If it is a triangle, means they are located at the corners of the triangle. Next is they are always located at the end of the developmental roots. You all know that roots are developed in the lobes, okay? And when these lobes join, they will form a developmental groove. So, orifices they are always located at the end of developmental grooves. These developmental grooves are darker. See, pulp chamber itself darker and the developmental grooves they are also called root canal map. They are darker than the floor of the pulp chamber. So, first thing, the canals are always at the end of the developmental grooves. They are not located in between. They are located at the ends of the developmental grooves. So, three rules are there. One is they are always located at the line angles of the walls and the floor. Second rule is they are always located at the angles in the floor wall junction. And third is they are always located at the end of the developmental fusion lines. They are also called as root canal map. They are also called as root canal map. Now, next is instruments. See, there are two type of instrument which are used in axis cavity preparation. This is the high speed handpiece, that is your air rotor handpiece, and this is slow speed handpiece. This is endo handpiece, which is used for canal preparation. Next is these are the different burrs which are used for axis cavity preparation. Most commonly uses round 2, round 4, round 6. Round 2 it is used when the pulp chamber is small, like your lower central incisor, lateral incisor, canine. Round 4 it is used for the premolars and for also for the central incisors. Okay. Round 6 when the patient is young and pulp chamber is big. In that case, round 6 it is used. Okay. So first, whenever you take the axis, whenever first entry into the pulp chamber it is done with the help of round burr. And the size of this burr depends on the size of the pulp chamber. Like in central incisor, the pulp chamber size is big, so you can use the 4 or you can also use if the patient is young, you can also use the 6 number pulp. Okay. Next is after taking a drop inside the pulp chamber, okay, you have to remove extra roof of the pulp chamber. This is where you are giving the entry inside the pulp chamber. Once you get the entry inside the pulp chamber, you have to remove remaining roof of the pulp chamber, and this is done with the help of round burr only. After that, the walls of the pulp chamber, they are made divergent with the help of your this tapered bud. Okay, but this is safe and tapered bud means at its tip there is no cutting grids. So there is no cutting grid, it is called safe and tapered bud. Okay, so with this the walls of the pulp chamber, they are finished and they are made divergent. Okay, so and combination of this is endo-axis burr. Here you can see it has a tapered diamond point. This is a tapered diamond point, and at its tip is the round burr. So it is a combination of these two burr is the endo-axis burr. Means you need not, there is no need to change the burr frequently. Okay, so with this round burr you take the drop inside the pulp chamber, and with this what you say, with this tapered part you will finish the walls of the pulp chamber. This is a transmetal burr. Whenever you want to take the axis cavity preparation through the metal or through the crown, see many times we make a access cavity through the crown. In that case, you have to use transmetal burr. You have to cut the metal. It will cause us friction. It will cause us more heat generation. So you have to use transmetal burr. Andesite burr, it is a carbide burr. It is also used for the access cavity preparation. It is used for finishing the external wall, finishing the walls of the pulp chamber. Next is this is the operating explorer. So this is used to locate the orifices of the pulp chamber. This is used to locate the orifices of the pulp chamber. This is Muller's burr. It is used. See, this is a long shank burr and it has a very small tip. So this is used for the calcified chamber. This is used for the calcified pulp chamber. Next is your endodontic spoon. This is used to remove the pulp tissue from the pulp chamber. Like your operating spoon excavator, this is similar to that, but only thing is this part. This is the is cutting part, or this is its working part. It is long, so that you can easily scoop out the pulp from tissue from the pulp chamber. These are the micro openers. Whenever pulp chamber or the canal orifices are calcified, canal orifices they are located with the help of micro openers. Okay. This is DG16. Again, the orifices they are located with the help of DG16 burr and JW17 Endotontic Explorer. Okay, it is similar like your operating explorer, but the taper is less and it is has more stiffness. This 16 and 17 indicates the length from this to tip of the explorer. Okay, so this is pointed, this helps to locate the canal orifices in the pulp chamber. DG16 is most commonly used explorer for canal orifice location. Whenever the canals are calcified and the orifices are blocked, in that case, we use these tips. This is ultrasonic tips with the ultrasonic instrument. We use this with this to remove the pulp stone, to remove the calcification over the canal orifices. Okay, so these are the endo tips. This is the ultrasonic endodontic tips, which is used with this type of ultrasonic instrument to remove the pulp chamber stones, to remove the secondary calcification from the pulp chamber. Over that, whenever the pulp chamber it is calcified, in that case, you can use surgical microscope. it provides magnification. Okay, it provides the magnification, so you can use this surgical microscope to see the canal orifices. You can also use loops, okay, but they are not that much efficient as that of the surgical microscope. You can only keep the magnified from 2 to 3 times larger than the original tooth size. So these loops are also used to locate the canal orifices. Now, before starting with your proper access clarification, you should know proper pulp chamber anatomy, and second is different canal configuration. So different root canal configuration. Otherwise, your root canal, or if you don't know how many canals are there, how many percentage of root canals are, like suppose all of you know that lower central incisors have one root and one canal. But if I say no, I got the two canals in the lower central incisors, it doesn't mean that I am wrong, but 80% of chance, and you are also not wrong. So 80% are the percentage in which single canal and single root and single canal will be there. But in 20% of the canal, in 20% of the mandibular central incisor may have uh, single root and two root canal. Okay, so for that case, this is I am giving an example. That for example, you all know that for lower central incisor, one root and one canal is there. But if you get one root and two canal, it is also not abnormal. In 20% of chances, in 20% of cases, there is chance that one root and two canals will be there. So, if you have in your mind that you will get only one root and one canal, it means there is chance that you may miss a one canal. So you should know different canal configuration. In this, you should know in which canal, in which tooth, how many canals are there, and what is the deviation in that canals may occur, and percentage wise you should know. Also you should know what will be the different shape and the different pattern of root canals, you should know. So that's why you should know the canal configuration. So different authors have given different, but the most common given by Win and the other is vertices classification. According to Win, type 1 is single canal at the orifice and the apical opening will be single. This is type 1 according to the Win. So in central incisor, type 1 canal it is very, in maxillary central incisor, type 1 canal it is very common. Next is two canal orifices while they are leaving the pulp chamber. But as they leave the pulp chamber, they become separate. And in apical one third, again they join. Means two canal, they join into one in apical one third. This is type 2 canal configuration. Type 3, two canals when they start from the pulp chamber, and two canals when they open at the apical area, means starting with two canals and ending with two canals. Next is starting with one canal, they leave the pulp chamber as a one canal, but in between they just bifurcate into two different canals. This is type 4 configuration. Next is vertices classification. In vertices type 1 classification, one second. In vertices type 1 configuration, this is another author, vertices, who has given different canal configuration. In this type 1, the canal while leaving the pulp chamber, it is 1 and it opens as a 1 apical foramen. This is type 1 similar to the given by Bell. In type 2, the canal orifices, there are two when they leave the pulp chamber and they join to form one canal in the apical one third. This is type 2. Type 3, the, its root canal starts as a single canal, they divide into two, and they again join to form a one canal. Okay, this is type 3 configuration. Type 4 configuration is while leaving the pulp chamber, there are two canal orifices and they open up as to separate apical foramina in the apical one third. Type 5 is single canal while leaving the pulp chamber and they bifurcate into two in the apical one third. This is type 5. Type 6 is two canals while leaving the pulp chamber, they join in the center and they again bifurcate into two. This is type 6. Type 7 is two canals while leaving the pulp chamber, they join and they again bifurcate. Okay, so this is type 7. Okay, 1. So here it is there 1, they separate into two, they again join into one and again they separate. Here they separated, they start with the separate canal, join into one and again they bifurcate. Here it is type A, there are three separate canals and three separate openings. So now starting with the proper access cavity preparation in anterior tail. Okay, so okay.